Hi everyone, this is the homework number 2 tutorial. The geometry is coaxial cable. I explained about it yesterday and I fixed the problem on the having minus impedance loss yesterday. Now the simulation is good to go. Okay, go to second place, second tab EM simulations. If there are lossless and lossy. These are two separate projects. What I'm going to do is I'm going to explain the lossy part. The lossless is much easier once you get the lossy. Here, again, go to setting. Make sure it's 1 gigahertz. Solid region. Make sure 2 conductors, 1 dielectric, and dielectric having permittivity of 2. Okay, and now look at this one. Electrical conductivity of the dielectric. See that in this case the dielectric, the plastic has conductivity of 1 Siemens per meter, which make it really lossy cable. Source, make sure you have 100 of them. Lumped element, sensors. I deactivated all of these so you don't need it, and I made overall field and port sensor activated. Boundary, don't touch anything about this one. Now go to grid and go to voxel and right click on it and make voxels, and it will ask you to save, so you save it. Now if you go to Reader, there's nothing because we need to run the simulation. Here is the simulation. Okay folks, now the simulation is done. First thing I want to make sure is just to go to overall field, go to E field and splice field view and say next and next to see what is inside. Okay, I'm going to go y equal to 0, which is exact at the center. Okay, now if you look at this, there is some electric field here, but it's not really, there is nothing inside. That is only because we have huge electric field, some outliers here. That's why the scale was wrong. Now let me just remove this one into the linear scale. I'm going to make this one as like 2. See, there is our electric field now. Again, animation. That's how the sine wave is going through. Now, but instead of using sine wave, we kind of talked about it in the class. We want to use the steady state, which is the magnitude of the electric field, magnitude of the sine wave actually. Here is the one, RMS modulus. This basically is a time average of each point. So you're going to see a electric field distribution something like this, and as you can see there is significant attenuation, and that's what it's supposed to have. So I would say this simulation is good. Okay, now let's go to port sensor, and here's your homework assignment coming. View UT is voltage in time domain. Go there. Okay, now what are we going to do is I'm going to import the data into my computer, and then it goes to export to the Microsoft Excel. Okay, go to right click on the screen, export dialog, go to text, clipboard, export. Now here's the tricky thing. First of all, you need to make this one as data. Follow me. Now you gotta make this one as maximum precision. Okay, because we are dealing with a very small number, we want to have a maximum precision. So export. Now all the data is in your computer memory. Go here, paste. Okay. So what I suggest you to do is to change the format cells into number. In my case, I just have 7. Okay. Now I'm going to remove this x-axis because this is the time which we don't need it. So and it's like 10 to the minus 9, like the value. Okay. Now go to SimeCAD again. Remove this. Let's go to IT. Right click on it. 2D curve plot view. Right click on it. Export dialog. Again, follow me carefully. Text, clipboard, export, data, maximum precision, export. Okay, now everything is on your computer to again paste, remove x-axis. Okay, now if you plot it, you will see something like this. We have very small current here. Okay, so what I like to do is first of all, you might want to do this one too. Like go to the bottom, select everything, and I'm going to insert, actually formulate auto sum maximum value. Okay, so this is the maximum of this column here. I'm going to do the same thing for the other side. Okay, go to maximum. Okay, so you see these two are the maximum values. Now what we need to do is calculate okay, so this divided by this, meaning voltage divided by current. What you get is this value here. Okay, now write this number down or copy and paste to somewhere. Okay, so that's your maximum value. Okay, what I'm gonna do is I'm going to increase, multiply this value to the current to make everything, to make the voltage current has the same height or value. Okay, there we go. So go down, Control V. Now let's just remove this one, and I'm going to have this one and that one. Select those two and make a line. There we go. Now you have perfectly matching height for voltage and current. Okay. Now what I'm going to do is removing some of these parts. Okay, if you remove this part, okay, you can actually sort of isolate one sine wave, right? Okay, I have done that already, and here is how it looked like. Okay, now you have two sine waves, and they have pretty much the same, sine height. Now you just have to read the value between here and here, right? And you can calculate what is the how much the phase has been shifted this way. Okay, now you have a phase difference, and you have the difference, the magnitude. So having these two, you can actually calculate the impedance. All right, that's it for your homework number 3 tutorial. Thank you. Good luck.